Okay, when we're working with a rate of change, there are 5 quantities that might possibly interest us.
The starting and final value of our first quantity, call it x.
The starting and final value of our second quantity, and r, the rate of change. And we'd like to come up with a somewhat easier way to work with these. Well, okay, keep in mind that r was a ratio, right? So that means that r was the ratio of the change in y to the change in x. So let's see. The change in y, that's yf minus ys, is r times the change in x, xf minus xs. If we know all but one of those values, this equation is going to be linear, isn't it? Sometimes we like to rewrite this by adding ys to both sides. And we say the final value of y is the rate of change times the change in x plus the starting value of y. Okay, that actually doesn't look too bad, right? Let's see an example of using this formula where we've already been told the rate of change. Suppose the price of a grommet starts at $3 and increases at a rate of $7 per year. How much does a grommet cost after 8 years? Probably the hardest part of this problem is deciding which quantity we should call x and which we should call y. But note the units on this ratio, dollars per year. R is in dollars per year. That means years are in the denominator, they should be x. And dollars are in the numerator, they should be y. So that means the price is going to be my y quantity, and the time is going to be my x quantity. Let's see now. We're told that r equals 7. We're told that the price starts at 3, and we want to know when it ends. As for the time, well, we have some starting time and a time 8 years later. I'm just going to say we start at 0 and end at 8, right? That's going to make the subtraction step really easy. So my final price is equal to my rate of change times my final time minus my starting time plus my starting price. That's just this formula with everything we know plugged in. This is just a matter of arithmetic, right? 8 minus 0 is 8. 7 times 8 is 56. And we get 59. Our final value of y is 59. Okay, so as we can see, this is very, very easy. If we're looking for the final value of y, it doesn't require any algebra. Let's see an example where we need some algebra. Suppose a small town has a population of 8,675 in 2006 and a population of 6,940 in 2011. If the population continues to decline at the same rate, what year will it reach 0? Okay, well, our cue that this problem is going to be about a constant rate of change is this phrase, decline at the same rate. So our first step is going to be to figure out the rate of change. And I think that population is changing relative to time. So we'll make our y quantity the population and our x quantity the time. Okay. So the starting time is 2006. The final time is 2011. The starting population is 8675. The final population is 6940. So our rate of change is going to be the change in y, 6940 minus 8675, over the change in x, 2011 minus 2006. Now previously I entered these into the calculator separately and then did the division separately. I could also enter the whole thing into the calculator in one go. And we'll take 6940 minus 8675 divided by 2011 minus, there we go, minus 2006. I'm going to look it over carefully and make sure I entered it properly. I'm going to hit enter. I get negative 347. The rate of change is negative 347. And now 2, we'll use that to get a new equation. I'm going to choose to still start from 2006. When the population was 8675. And now I want to know the year when the population is 0. Okay, so I have this formula, which means I just need to plug in what I know. Right? My YF is 0. My R is negative 347. My XF is what I want to know. My XS is 2006. And my YS is 8675. Okay. So it looks like this is one of those equations where I need to simplify first. So I'm going to rewrite my subtraction as plus the opposite, and now I'm going to use the distributive property. On the left I've still got 0. Here I have negative 347 times XF plus negative 347 times negative 2006 equals 696082 plus 8675. Okay, let's see. And now these are like terms. I can combine them. And we get 704757. Let's see. So what's keeping my variable from being alone? Well, it's being multiplied by something and added to something. I'm going to get rid of the addition first. Negative 704757. We'll multiply both sides by 1 over negative 347, and we get XF is 1 over negative 347 times negative 704,757, 2031. Okay, what were we doing again? What year will the population reach 0? The year 2031.